Hello and welcome back. In this video, we learn about the concept adiabatic compression. To understand the concept of adiabatic compression of a fluid, consider this example. Air is kept in a container as shown in figure. Let the pressure be P1, volume, V1 and temperature, T1 inside the container. Imagine that the air is compressed by a force F acting on the piston so that the air is compressed, increasing its pressure and decreasing its volume. Let P2, V2, and T2, R pressure, volume and temperature respectively, for the air at the final equilibrium condition. If this process is frictionless and no heat is exchanged with the surrounding during process, it is called an adiabatic compression or expansion. For an adiabatic process, P divided by ρ raised to K is a constant where K is the ratio of specific heats. Consider this example. 1 meter cube of air contained in a rigid cylinder is at 100 kilopascal. This air is compressed adiabatically to half its original volume. Calculate the final pressure inside the container. We have seen earlier that for an adiabatic process, P by ρ raised to K is constant. Using this relation, we can derive a relation between pressure ratio and the ratio of densities at initial and final states. Since the mass is constant, density ratio can be related to the volume ratio at initial and final states. Finally, we can find the final pressure from this relation. Consider another example. 2 meter cube of air in a rigid cylinder is at 100 kilopascal. This air is compressed adiabatically to 1/4 of its original volume. Calculate the final pressure inside the container. We have seen earlier that for an adiabatic process PV equals constant or P by ρ is a constant. Using this relation, we can derive a relation between the pressure ratio and the ratios of densities at the initial and the final states. Since mass is constant, the density ratio can be related to the volume ratio at initial and final states. Finally, we can find the final pressure from this relation. Consider this example. 10 meter cube of air contained in a rigid cylinder is at 1 atmospheric pressure. This air is compressed adiabatically to 6 atmospheres. Calculate the final volume inside the container. We will solve this in class. Finally, the summary is presented as a cognitive map. For a fluid, undergoing an adiabatic process, from a state 1 to state 2, the ratio of pressure to its density raised to K at each state will be a constant where K is the ratio of the specific heat. Thank you for listening.